All right, thank you everyone for your patience. Good afternoon. Mr. Minister, Ambassador Agency Cryosphere process that began in 2018 and led to the creation of AMI last year. So please, Mr. Gordano.
Thank you very much. Good afternoon. And first of all, let me express the apologies of the Minister of Environment of Chile, who was scheduled really to be here with us today to pronounce a few opening remarks. Unfortunately, she had to take a earlier flight, so she's actually on her way to the airport at the moment. So her apologies for that. But at the same time, she asked me to convey our commitment to AMI, to the initiative, to the importance of the the importance of the awareness of how climate change is affecting the cryosphere in general. And as you know, and as many countries represented here, and of course I have the honor also to speak on the presence of the Minister of Norway, and Norway being such an important partner in this. We know the importance of the cryosphere. Chile is a mountainous country that has many glaciers that serve as a security for the water supply of our cities, of our population, and that has been affected by climate change in the last decades. That is clearly something that is of concern. And of course, the dynamics of the cryosphere is also something of concern, because as much as we can take action in order to protect our glaciers, in order to protect the supply of water, at the same time, we see the phenomenon in the dynamics of climate change affecting almost irreversibly the loss of ice mass, and therefore the ability of the mountains to continue providing water to the population. So, and this is why what I wanted to say here today is that our main motivation, and this is great that we met Pam and the organization ICCI to create some sort of intergovernmental discussion about this and how we can make this connection and make sure that parties under the UNFCCC, but in general governments and civil society as well, are more aware of the importance of advancing mitigation adaptation, mitigation ambition in the combat to climate change, because that is the most effective way to conserve and to preserve our cryospheres. And of course, we are talking from Chile, from a country that is very much in the south, with all the glaciers, but also Antarctica is something that is of great concern. The Antarctic Treaty, of course, governs all the scientific activity in the Antarctica, but at the same time, we cannot but to underline that Antarctica holds most of the ice in the planet, and therefore it is so important that we keep the equilibrium, the balance between the Antarctic ice also there. But of course, the permafrost is something of great concern as well. So I wanted to say that. I wanted to say that the AMI initiative, the Ambition for Melting Ice initiative, born in COP27, was precisely to create this awareness around the importance of increasing ambition in mitigation, reducing CO2 gases and all greenhouse gases in general, just precisely to show what will happen if we don't do this, what will happen if we don't stick to the Paris Agreement, what will happen if we don't stick to 1.5. The consequences are going to be catastrophic, and that will be mostly felt through processes that are related to the cryosphere. So this was the original idea, and we at the national level, this was my second point, at the national level we have been taking steps in order to do this. The glacier protection in Chile has been a long discussion, and there's been a number of legal initiatives in order to protect the glaciers. Recently we have adopted a framework law on for biodiversity and protection areas, and that includes, of course, the glaciers that are within those areas, those protected areas. And that would have a series of implications. One of those is, for example, that we will have
Thank you so much, Julio. Our next speaker is Minister of Climate and Environment, Espen Barth Eide. He has worked for decades and with multiple Norwegian governments as an expert in security and foreign affairs, serving as both Minister of Defense and Foreign Minister, and as Deputy Minister in both Foreign Affairs and Defense as well. He became the spokesperson for climate and energy affairs for the Labour Party in 2017, and then Minister for Climate and Environment in 2021. That someone with such a deep and broad background in security issues is now in the climate field says something, I think, about the implications we are facing, again, especially because of the reaction of the world's ice stores if we cause today's temperature rise to continue. Mr. Minister.
Thank you, Pam, and thank you, Ami and Julio. Good to see you. We're very happy to work so closely with Chile and, of course, with Iceland and with all the other friends in Ami. I think this is an incredibly important initiative. I was very happy when we signed it almost a year ago in Sharm el-Sheikh. And I think it is very apt that we have a number of countries members of AMI who are not, as you said, not Arctic or Antarctic countries, but who take an interest because it's really a global issue. And I think that's sort of message number one. Everybody should care, even if you live in the middle of the equator, you should care about this, because the refrigerator effect of the Arctic and the poles and the importance of keeping the ice where it is and avoid melting matters really to the whole planet. And I've been here in New York this week, but last week I was in Svalbard or Spitsbergen, which is way north of Norway. It's actually the last land mass before the North Pole. And I go there quite often because my ministry has several operations there. And you can actually see the change with your own eyes almost from visit to visit. At least when you go with a few years distance, you can really see less ice and you can see the changes. We have a research station at Ny-Ålesund, which is it's a very beautiful place. It's almost at 80 degrees north, and I think, Pam, you've been there. And we have sort of world-leading research and international research community studying global change, so not only Arctic, but global change, because you're so far away from everything that you have an excellent place to do background mediation of ppms and so on. But what is quite interesting is that when the researchers come home from their research, they go into a building which is cracking up because the permafrost is melting. So you can see sort of climate change on the big picture on your screens and on your instruments, and you can see it beside your bed when you go home, and you have to invest quite a lot of money to keep this building safe, because they were, of course, laid straight up on permafrost, as one did in these places, and now it's breaking up because of the same global warming. That's the least of our problems, but it's a symbol of a much bigger problem. And with that permafrost thawing comes the methane leaks, which then accelerates and locks in even more warming effect. And with the loss of ice, there's less reflection, because ice is white and reflects light, but then when it becomes darker, also reflection goes down. This is, of course, first and foremost a problem that is created by global emissions. So, you know, the message number one, to save the poles, we need to save the planet and we need to get emissions down. But there are also things we can do locally. For instance, we discovered that SOT, black carbon, if it's emitted close to the Arctic, it has a higher warming effect. I mean, we shouldn't emit it at all, of course, but it's even worse. So it actually has a number of local efforts. And Secretary Kerry, when both of us were foreign ministers, I remember he was an early driver of using Arctic cooperation to also to dedicate it to these sort of local drivers of climate change that can actually happen in the Arctic. These are beautiful places, but you can see the change very fast. There is actually nowhere on the planet on land where the changes goes faster than Svalbard. So in my country, it's actually the place on landmass where the warming effect is sort of goes fastest. Of course, the starting point was cold, so it takes time before you find it very warm there. But relatively speaking, you can calculate up to 4, even up to 5 times the global average in the Arctic. So that's how fast it goes, and this is then being exacerbated. People, of course, also study the flora, the fauna, the marine environment, and they are now saying alarm, because what used to be a sort of very complex Arctic marine environment is gradually being transformed into an Atlantic marine environment. And that has to do with sort of changing temperature, of course, but also with changing currents, and which brings other species, which shocks with the species that are already there. And the changing currents also means that this refrigerator effect, this refrigerator service for the planet becomes less effective. Again, which will then exacerbate global warming elsewhere. I also this year had the pleasure of visiting the other pole, where the Troll Station in Antarctica, which is an area that, of course, also Chile follows very closely. We are fortunate enough to have our research station on land. It's on sort of a high land above the ice, which means it stays put. But many of our colleagues' stations are on ice, and they actually keep moving. So it's actually, you know, it's a practical problem for researchers that, you know, every day you wake up and the research station is not exactly where it was yesterday, because ice is moving so fast. And the problem we see there is melting from below, which is really the phenomenon that researchers are pointing out now, that the melting seems to happen sort of from below this ice mass. And when you go down and through the ice, you have to you don't have to go so far down before you find you know, floating water than you did before. So it's really, really a serious issue. Norway recently took over as the chair of the Arctic Council, which post we'll have for 2 years. It's complicated times, of course, because a key member of the Arctic Council is Russia, and relations are not, to put it carefully, as good as they used to be. But the Council is still there, and we agreed to emphasize precisely these issues. We have 4 priorities for our presidency. It's focused on oceans, and of course particularly Arctic Ocean and Arctic Ocean health. It's Arctic climate and environmental issues, sustainable economic development, and people of the North. And the reason we choose these issues, the Foreign Minister and I, and we decided to, you know, have this as the focus, is number one, it's important in itself, but it also areas where cooperation could to a certain extent still continue, because we need to uphold at least what we already have in order to get the knowledge, the insights, the data that is necessary to follow this closely. So we will definitely use our chairmanship of the Arctic Council to work, or chairship it's called now, because we don't do men, over the Arctic Council, and we'll use that as one of the channels. But this is also, of course, to bring this message to the world, which we do with Chile, with Iceland, with New Zealand, with others, that people need to care about the Arctic, because what's happened in the Arctic does not stay in the Arctic, or what happens in Antarctica, just well say, will not stay in the Antarctica. It really, really is a symbol of something serious going on the planet that we share. So I'm very happy that we have this cooperation. I'm very happy that IMI exists. I was happy when we signed it, and I'm glad to see it's developing further. And again, we really need to have solid research and solid dissemination of that research, and then really use this to drive policy change. I have been asked by the presidency of COP28, Dr. Sultan Al Jaber, together with Minister Grace Fu of Singapore, to lead the ministerial consultations on mitigation. MISA is in another group of this ministerial consultation as well. So jointly, so Maisa Rojas, the Minister of, sorry to be so personal, the Minister of Environment of Chile, and we will cooperate very much towards COP28, as we did at COP15 on biodiversity less than a year ago. And we really hope to use this as a platform to make people understand the importance of understanding the cryosphere and what it tells us and what we need to do more of and less of in order to save the planet. And in order to save the planet, we must look after the health of the polar regions. Thank you.
Thank you, Mr. Minister. So we will now move, actually, this is a good introduction, because we're going to move to the science behind the slogan of why 2 degrees is too high, for the 5 elements of cryosphere that have global impacts and implications. So in order, and if you could come up and take a seat, please, to the side, Dr. Robert DeCanto of the University of Massachusetts Amherst and a multiple IPCC coordinating and lead author. Ms. Mira Khadka, an early career scientist from Nepal studying at Carnegie Mellon, who will be speaking on glaciers and snow. I'll actually be channeling a presentation from 3 leading scientists on polar oceans. IPCC author Dr. Christina Schadl, Woodwell Climate Research Center on permafrost, and winding up, Dr. Twyla Moon from the National Snow and Ice Data Center and University of Colorado at Boulder on sea ice. We will be moving very quickly, so hold on to your hats, and Rob, please take it away.
Thanks, Pam. Do I have a...
Clicker is here.
Wonderful.
Yes, you have to point it to the back of the room. And I should have put these people up beforehand, but now you have their names. So you can point it to the back.
Got it. Okay. So I'm going to be talking about the 2 massive ice sheets on Greenland and Antarctica, and hopefully instilling, again, this urgent sense that 2 degrees is too much warming for them. So just to remind you all, there is an enormous amount of ice locked up in these ice sheets. Not sure what just happened with the lights. Okay, we're okay. So they're collectively combined, these ice sheets hold enough ice. It's the equivalent of about 65 meters of potential sea level change. So even a really small change in these systems could have monumental impacts on low-lying places around the world, of course. And this, I like to show this slide. I study this system, particularly Antarctica. I've done field work there, and it's hard to fathom the scale of this and how much ice there is locked up in Greenland and Antarctica. Antarctica has about 8 times more ice and potential to cause sea level rise than Greenland. So both of these ice sheets are losing ice to the ocean, contributing to sea level rise, and the rate that they're losing ice, both of those ice sheets, is accelerating. Of course, we want to know how sensitive they are to warming. And I think there is a really clear, powerful message from the geologic record. This is our colleague and friend Andrea Dutton. She's a professor in Wisconsin. She's a geologist, and she maps ancient shorelines around the world. She is standing on a coral reef in the Indian Ocean basin, 125,000 years old. This is also a 125,000-year-old coral reef, but in the Florida Keys. Coral reefs don't lie, right? They were living in water. These corals 8 meters higher than today. Now, what's important about this story is that this is a time when the world was perhaps even less than 1.5 degrees warmer than pre-industrial. At this time, it is clear This is clear evidence that the ice sheets are sensitive to even a modest amount of warming. And if we go even further back in time, the Pliocene, 3 million years ago, perhaps 3 degrees warmer than pre-industrial, and geologists are telling us there could have been 20 or more meters of sea level rise relative to today. So again, geology is telling us that these ice sheets are indeed sensitive to a little bit of warming. Now, of course, the IPCC has been updating the projections of future sea level rise coming from these ice sheets and from thermal expansion of the oceans, and trying to give us some guidance as to what to expect in the future. There's a very clear message, and that is that the low emissions scenarios out to the year 2100, roughly half of the potential sea level rise. Within the century, emissions matter at the point of essentially doubling the potential for sea level rise. And then we see that the IPCC included this dashed line, an outcome perhaps way outside of the likely range of the projections. And this is coming from some new emerging science suggesting that there could be instabilities in these ice sheets that we hadn't really been accounting for until now. There hasn't been enough work done on these processes to include in the main projections, but the IPCC in the AR6 felt it was really important that we understand that we could not rule out 1.5 or more meters of sea level rise within this century. And if we have a longer term perspective, thinking a few centuries into the future, which we really should, we see what they said. 15 meters by 2300 could not be ruled out if these instabilities were to be triggered. The instabilities in the latest modeling that's being done happen when the temperatures are above 1.5. And as you'll see in the next couple of slides as we wrap up, that it makes all the difference to the world, 1.5 versus, for example, current policies in the threat of maybe following that dashed line. So since the AR6 was published, there is a continually growing amount of evidence of studies, modeling work, state-of-the-art climate and ice sheet models that, again, show time and time again low emissions. So this is temperature rise out to the year 2150, following a scenario that is essentially compatible with the Paris Agreement. This is what the ice sheets do with those low emission scenarios. But with the higher emission scenarios, you can see that every line here with the higher emission scenarios is quite a bit higher. There is clearly a critical role of policy, whether or not we follow a future like this in terms of sea level or something like this, is clearly directly going to be driven by policy and what we do in terms of our urgent need to mitigate. So I am going to, just for the sake of time here, just one more study I want to share. This is one of mine. This was published in the journal Nature about 1.5 years ago. And I've been focusing mainly on Antarctica, again, because of the huge amount of ice there and its potential to cause really devastating sea level rise. And these are simulations, again, that follow different emission scenarios. On the top is an emission scenario that is following emissions that get the world to just about 1.5 degrees relative to pre-industrial in the year 2100, and this is important, with no overshoot. The red curves are the rate of sea level rise that is being contributed, in this case, by the Antarctic ice sheet. So this doesn't include Greenland or mountain glaciers or thermal expansion. It's just the role of Antarctica. So this is a 1.5 degree C scenario. This is what the same model does when we follow current policy, the NDCs. And what we find is that around mid-century, around 2070, there is a huge uptick in the pace of mass loss. These instabilities are being triggered in the ice sheet that is essentially causing an order of magnitude increase in the pace of ice loss and contribution to sea level rise. In this scenario, so this is just following the current policies, essentially, Antarctica alone would be contributing about 1 centimeter of sea level rise per year, probably beyond the limits of adaptation in a lot of places around the world. Again, I cannot think of a clearer message. 1.5 degree world, where yes, Antarctica will continue to contribute to sea level rise, There will be challenges in many places around the world, but it's about how fast that sea level rise is going to happen. We want to buy as much time as we can for our low-lying places around the world to be able to prepare and to be ready to adapt. We do not want something like this to happen. So we can make a difference, but we need to start now. And then I would say that my final message in all of this is that once these sorts of things begin to happen within the ice sheet to really begin to deliver a lot of ice, it's very hard to turn this around again. In fact, we should all understand that every bit of sea level rise that is being caused by the loss of ice on these ice sheets, in terms of societal timescales, is permanent. We're not going to turn things around. We can hopefully slow things down, but we're not going to go back to the sea levels that we had a century or more ago. Thank you. It's okay. Do I have time? So Pam, I know she was pushing me to be quick, and I'm usually not very good at doing that. But these are powerful messages. So these are the sorts of challenges a meter of sea level rise presents in a place like the Bahamas. And the areas in red are inundated. Okay? Now, we'll probably be seeing this sort of order of magnitude of sea level rise in a few centuries. That's what 3 meter looks like. And it's not just the Bahamas that are going to be facing this level of inundation. So we want this to be happening around the world as far away in the distant future as possible. And it's going to be all about reaching that 1.5 target. 3 degrees is too warm. It may be 2. Thanks, Pam.
So, Mira, please.
Thank you, Pam. Good afternoon, everyone. I'm Mira Khadka. I'm from Nepal, and currently I am a PhD student at Carnegie Mellon University in the US. My research is focused on glacier model projections and by utilizing the vast amount of satellite data set that exists today. So I work on mountain glaciers all around the world. And the work that I have been doing, it is very close to my heart because I deeply, deeply sympathize with the people living in the mountains. I have personally, firsthand experienced the impacts of climate change, from flooding to avalanches, and also this feeling of helplessness when your voices are ignored. The mountain communities back home in high mountain Asia, they are already struggling with extreme poverty and geopolitical issues, and climate change is making that worse. So moving forward with the presentation, I would like to take your attention to this very important question that we are addressing today. Why 2 degrees Celsius is too high for mountain glaciers and snow? So today we have been watching mountain glaciers disappear all around the world. And let me remind you, right now we are at 1.2 degrees Celsius compared to the pre-industrial times. And between 2022 to 2023, the Alps lost 10% of glacier ice. And in southern hemisphere, Amicocher, Chile has been experiencing record high temperature in winter, and this will cause unprecedented water shortages for hydropower. And Norway has already faced such water shortages for hydropower last year because of low snowpack. Yeah. So why saving glaciers, ice, and snow is important? There are places like Tarim Basin in the northwest China, and also the Aral Sea Basin in Central Asia. So almost 100% of freshwater resources come from the mountains in summer. And I would like to mention that in the Tarim River Basin is the world's largest cotton production region. So whatever happens in Tarim River Basin, it matters to every country in the world that consumes cotton. So it's not only whatever is happening in high mountain Asia, like Rob mentioned, it affects everywhere in the world. And I would also like to highlight that there are millions of people living in the mountains and billions of people living in downstream who rely on these freshwater resources for drinking, hydropower, agriculture, and so much more. Okay, so with all this in mind, I would like to emphasize that we have 2 choices. And these figures, they show the difference, the significant difference between 1.5 degrees Celsius and 2 degrees Celsius. I would like to take your attention to the blue line that signifies 1.5 degrees Celsius of warming, and the orange lines that signifies 2 degrees Celsius of warming. So when the curves, they reach x-axis on the bottom, when they touch the x-axis, that means 0% of glacier ice is remaining. And the glaciers disappear. And at 2 degrees Celsius, tropical glaciers, nearly all tropical glaciers will disappear, and most of the mid-latitude glaciers will be gone. And I would also like to mention that the restoration of these glaciers will need temperatures well below that of today, and that will take centuries to millennia. And the case is very similar back home in Hindu Kush Himalaya. So at 2 degrees Celsius, almost 50% of glacier ice that we have today, that will be lost at 2 degrees Celsius. So at 2 degrees Celsius, we are not only losing glacier ice, but we are also losing snow. So the precipitation that would normally come down as snow, that will fall as rain at 2 degrees Celsius. And unfortunately, rain doesn't provide the storage capacity for reliable seasonal fresh water. So, and the consequences will be felt everywhere in major cities from Delhi to Marrakesh to Los Angeles, and that's huge. Okay, so we have two choices. At 2 degrees Celsius, we will have extensive, long-term, and irreversible ice loss, and that will affect millions and billions of people living in mountains and downstream. And we will be compromising the lives of all those people, and we also need to remember that we will be forcing those people to face the limits, to face loss and damage beyond the limits of feasible adaptation, like Pam mentioned earlier. But I would like to highlight that we don't have to go down the road of 2 degrees Celsius. We can choose 1.5 degrees Celsius if we can make sure that we limit our fossil fuel emissions, and we can have our temperature at 1.5 degrees Celsius, or briefly peaking 1.6 degrees Celsius. That means that the tropical and mid-latitude glaciers, they might actually start to slow down. The loss of those glaciers might start to slow down by 2060. And they might actually stabilize by 2100. And some of the glaciers, they might even show regrowth. And snowpack will start coming back sooner. Isn't that amazing? Yeah. So as I conclude my talk, I would like to emphasize that we all need to accept that 1.5 degrees Celsius is the limit to save our snow and glaciers. And if we do that, we will be able to save these crucial resources for the generations and generations to come. Look at them smiling. Children from the mountains. Yes, that's the goal. So the choice is ours. Thank you.
So we're going to be switching it up a little bit now. And as I mentioned, I'm going to be channeling these three very eminent polar oceans researchers, Elise Drost at AVI, Helen Finley, PML, and Sean Henley at the University of Edinburgh. They could not be here today. And I'm going to be talking about the polar oceans. Now, these are not frozen, of course. And so technically you may not call them a part of the cryosphere, but they're actually a very important part. And it's a different way of talking and thinking about cryosphere and climate change that is really important, because they face three threats, really. Warming, obviously from global warming, but from CO2, which I'll come back to. Freshening from the melting of the ice sheets, which really impacts the species that, of course, are marine species, and so they're used to saltier water, and acidification. And I'm going to be focusing today on acidification, mostly because of lack of time, but also because it is the longest lived of these three dynamics, which are so important. The issue with acidification or corrosive waters is that existing shells will corrode, young animals that are building shells will not be able to build those shells, and therefore they won't survive into adulthood. And also, more corrosive waters can affect even non-shelled species. It affects their metabolism, it affects their ability to reproduce. And the issue with this is not just warming then, it is CO2. And it's important to think about how unprecedented the levels of CO2 are today, because for the past 3 million years, we've been below 300 ppm. For the past 30 to 50 million years, we've been below 400 ppm. And this is where we are today. 2023, we reached 424. In a sense, that's the only number that really matters. And 2023 will be remembered as the year that CO2 concentrations in the atmosphere reached 50% above pre-industrial, with very little attention, actually, to that breaking point. Why is this important for our oceans? Because the Southern and the Arctic oceans are the oceans that are absorbing more CO2 than all of the rest of the oceans on the planet. Colder, fresher waters absorb CO2 more quickly. That's the simple layperson way of putting this. What that means, though, is that they're acidifying more quickly than the other oceans of the world. And the issue with acidification is that it is more irreversible than any of the other cryosphere dynamics. You know, ice sheets might grow back in 20 or 30,000 years. Acidification lasts for 30 to 70,000 years. It takes that long to buffer, and it is set entirely by whatever our peak CO2 level is going to be. So you see here that even with low emissions, the blue line, there's still a much, much lower pH, higher acidification in the oceans. And so for polar oceans, for example, 1.5 is a peak of 430. 2 degrees is a peak of 470. 450 has been set as a real important threshold for the polar oceans for quite some time now. And we're getting very close to it then, even with the 1.5 degree to the right graph here. But as you can see, we're passing that threshold where shelled organisms can survive already in 2050 with the level of emissions that we're seeing today. This is what the world could look like. Even at 1.5 degrees, you can see that there are parts of the Arctic Ocean and there are other hotspots in the Southern Ocean that will not be able to support shelled life. But if we get up to a 3 or 4 degree level, the entirety of the Arctic Ocean, some really important fisheries, and the entirety of the Southern Ocean will not be able to support shelled life. And that is a real choice for us. And again, that is going to be set by how high CO2 levels go. The higher they go, the more portions of the ocean that are going to be affected, and we're seeing shell damage already today. These samples were actually taken in the Southern Ocean in the 2000s. And so this is the kind of damage that was occurring then, and that shell damage is increasingly spreading. It's being seen over and over. One of the leading researchers on this is saying that, you know, things that we used to have to do to animals in the lab, we're now being able to see in the wild because of this. And so here is just one example then that is very, very relevant to our Norwegian and actually Italian friends, because there is a hotspots in acidification in the Barents Sea and around Iceland, which is where the cod have their spawning areas. And so they will be very, very affected by this. But then you have to think again about those 3 threats that I put in the beginning. You have warming and you have freshening going on. So if you think about the situation of the cod, they're being pushed southwards by growing acidification. They're being pressed northwards by warming waters, also by invasive species, also by meltwater coming off. And eventually they get sandwiched in between these 2 things, and there's no place left for them, at least not in the wild. And so we're facing a really difficult situation, perhaps extinction in the wild of this very, very keystone species. So polar oceans, then, takeaways. They're far more sensitive to rising temperature and CO2 than the other oceans. Some of these changes are irreversible. We will already see some damage at 1.5, significant damage at 2 degrees. But if we can stay close to 1.5, as close as possible to that 430 or at least below 450 ppm, then we can act now and we can halt that rise in CO2 and really prevent the worst. And again, go back to an earlier slide. If we're going at 2.5 ppm per year, then we will breach 430 within 5 years. We will reach 450 in about 11 years. So the time is really running out. So with that, I'm going to turn it over to Christina to talk about another CO2 kind of a thing, permafrost.
Thank you. I just wanted to say I'm going to add to the CO2 problem with what I'm going to talk about. So I will tell you a little bit about permafrost. Usually you actually can't see permafrost because you're standing on top of it because it's underground. But in this picture here, we're looking at an eroding hill slope, and you can see the active damage that's happening when permafrost is thawing and degrading. Here I'm showing you how much permafrost we currently have. I should clarify, permafrost means frozen ground, and it is permanently frozen. It contains ice and rocks and soil organic matter. And all the components matter for different reasons. So here we're looking at the current permafrost coverage. The teal color shows you where there is permafrost, at least to some extent, and the closer to the North Pole in the center of the graph here you go, the more continuous permafrost is, and the further south you go, the more it becomes patchy, and that's also where it's going to disappear the fastest and the soonest. And we're in this next image, I can show you that by 2100, under a low emission scenario, which should keep temperatures below 2 degrees Celsius, all of the lightly colored teal color means the permafrost is gone. So if we keep temperatures to about 1.5 degrees, we still lose about 40% of permafrost. With every 1/10 of a degree that we go above that, we just keep losing more and more permafrost, and it's not going to come back anytime soon. So this here shows really by 2100, we already are committed to losing a lot of permafrost. And the reason we care so much about permafrost is there's a lot of local damages happening that I'm not going to go into, but for the global, for everyone on this planet and everyone in this room here, it really matters that there's so much carbon locked up in permafrost. We know that there's about 1.5 trillion tons of carbon in permafrost, and that's about twice as much carbon as we have in the atmosphere. It's a lot, and it is currently underground, it's locked up, and we want to have as much of it stay there as possible. And with climate warming, the permafrost starts to thaw. The temperatures become warmer. The microbes that live in permafrost, they enjoy it when it gets warmer. They become more active, and they start decomposing the organic material. And by doing that, they release greenhouse gases to the atmosphere, and that's carbon dioxide and methane. And the more greenhouse gases we have in the atmosphere, the more climate warming we have, and that thaws more permafrost. So it's this really vicious cycle that gets reinforced. Now, permafrost emissions matter because they really decrease our so-called remaining carbon budget, because as Pam was saying, there is going to be more carbon dioxide emitted to the atmosphere, and here these two bars show remaining carbon budgets depending on the degree of warming that we do not want to exceed. So for 1.5, it's a smaller remaining budget than for 2 degrees Celsius. And if you're also accounting for permafrost carbon emissions, they actually eat up a lot of that remaining budget, which means for policy decisions, there is even less carbon remaining than we kind of think that we have, because we need to account for these natural emissions as well. And then I always want to stress that permafrost emissions are not bigger than human emissions, but they are really big, and they are at the same scale as some larger country emissions, even today. So here we're looking at 1.5 degree, 2 degrees, and then 3 to 4 degrees even to the right. And we are expecting that by 2100, 150 to 200 gigatons of carbon are being emitted from permafrost, which is about the size of what India is emitting today if we were cumulatively accounting for all the emissions. If we go to 2 degrees, that becomes 220 to 300 gigatons, which is about the EU emissions. And if you go even further, then we come to the US and China emissions. So it's really like a scaling thing. The warmer it gets, the more carbon is coming out. And my last point is that even if we were to stop all of the warming right now, we already have committed a lot of carbon dioxide to come out of permafrost, because it's a very slow moving process. So thawing is starting and is happening right now, and future generations really must already deal with everything that's happening now, and the more we are letting it happen, the more they will have to deal with it. So it's a little unclear how big these numbers are, but they are just going to be bigger and bigger. They're not going to get smaller, and also the carbon is not really going to go back into the soil, even if we do stop with warming. So it really matters to start doing this as soon as possible. Thank you.
The last question we'll ask is, why is 2 degrees too warm for sea ice? Arctic sea ice is an issue that we've been hearing about for more than a couple of decades. Since 1979, we've been seeing a 13% decrease in Arctic sea ice extent every decade. But that really represents a regime shift that happened around 2007. The last 17 years have been the lowest 17 years of Arctic sea ice extent. We know that that kind of number represents a direct relationship between how many tons of carbon dioxide we're putting into our atmosphere and what area of sea ice loss we're experiencing. But sometimes when we're looking at this map view, we aren't appreciating some of the losses that come along with this extent, which is to say that we're losing much of our old multi-year thick sea ice, which is critical as habitat. It's critical also for many coastal communities as sea ice helps protect them from erosion, storm, and wave action. And we've seen a reduction in the late 1980s. We had multi-year sea ice that was more than 4 years old, covering more than 2.5 million square kilometers of the Arctic at the low in September. Now, in the last few years, we're at less than 200,000 square kilometers of multi-year sea ice. Now, unfortunately, recent research shows that we're seeing larger and faster losses of sea ice. So it's happening more rapidly and at lower temperatures than expected. This, of course, means that we're moving towards not seeing any multi-year sea ice and moving to an entirely seasonal sea ice system in which at just 1.7 degrees Celsius, we would be expecting full loss of our summer sea ice in the Arctic. So well below that 2-degree number. Unfortunately, we've been ignoring for many years the Antarctic, but it's now reminding us that that is also an important area of sea ice on our planet. In the last 7 years, we've set 3 new records for Antarctic sea ice minimum. The Antarctic sea ice minimum comes at about February of every year. This is a picture taken from a ship in the ocean near Antarctica. And you can see here, February 2023, just earlier this year, there's no sea ice in view, and we're only 2,000 kilometers from the South Pole itself, and we are in view of the ice sheet. So we're not in a distant space, and this February 2023 represented a near 40% decrease in the sea ice extent over this long-term mean extent. And this sea ice around Antarctica, just as sea ice is playing a critical role in the Arctic for protecting shores, in the Antarctic it plays a very important role not just for habitat, but also for protecting the ice sheet itself from wave action. We don't know exactly what the implications for this are, but we know that there's really only one direction, which is that there has the potential for it to increase our losses of our ice sheet itself and therefore influence sea level rise. We've heard across all of these presentations how changes in the Arctic are arriving at our shores, far from it. Changes in Antarctica are bound to be arriving at our shores and are to some extent now. We see in the mid-low latitudes tremendous impacts from losses of snow, ice, how the thawing permafrost is additionally adding to heating of our atmosphere. And we can think of even more ways in which polar changes are influencing our mid and low latitudes. For example, as we're warming our Arctic, we're creating a weaker, wavier jet stream, resulting in more extreme events. Thinking about those global weirding events when suddenly people in Texas are worried about their water pipes bursting, right? So just as we heard from the minister earlier, what stays in these what happens in these polar regions does not stay in these polar regions. So just to review some of the things that we've looked at and get a sense that there truly is no negotiating with the melting point of ice, and that we do meet critical cryosphere limits beyond this 1.5 degrees. So as we think about Arctic sea ice, summer loss occurring at a very near temperature, 1.7 degrees Celsius. While this may be reversible on a 100 or multi-100 year time scale, adding heat to the ocean is only making this reversibility a longer term process. With glaciers and snow, we begin to see near total loss of tropical glaciers at 2 degrees, substantial losses before that. And again, this is a multi-centurial process in order to see reversibility, and it's very hard to grow back these kinds of extensive ice features. Other things that we've heard about today fit into the irreversible loss category, certainly on a multi-millennial scale or human time scale. Permafrost increasing our carbon dioxide and methane in our atmosphere and continuing to have emissions past our peak temperature, irreversible. Polar ocean acidification, again determined by our peak carbon dioxide, not where we're arriving in 2100. And we've already observed biological damage, which will only expand as we get into the future, making oceans potentially unlivable. And ice sheets and sea level, where we know that we have long-term committed sea level rise, some already baked into the system, but the potential for these rates to really increase become unadaptable, and for us to see extreme levels that are entering this double-digit sea level rise. Again, irreversible. So risk and damage from cryosphere largely depended on that peak temperature. We can't just have our eyes in a far distant future. We have to understand every 10th of a degree that comes along, and every 10th of a degree matters. And then, of course, is all of this possible, right? Well, the science is clear. Geophysically feasible, environmentally feasible, technologically feasible. And we know economically, not only feasible, but if we're able to take a multi-decadal view, economically advantageous. The questions right now lie here: institutionally feasible, socially and culturally feasible. That's where our action space is, and that's on the shoulders of all of us. So again, that we can't negotiate with ice. We know every 10th of degree matters, and we know that it's truly within our hands for making this decision and taking the necessary action. Thank you.
Thank you very much. I'd like to thank all of the scientists who've spoken. And I wanted to move on in the interest of time very quickly into from science to policy. And I think we'll keep this up because it's a very appropriate way to begin ending this session. First up then will be Mr. Ashok Adesiam, who is Head of Global Affairs for the United Nations Oceans Conference in 2025, Deputy of the Special Envoy of the President of France, with a very special announcement. Please.
Thank you very much. First, congratulations for putting this meeting in reunion. I'm saluting my colleague from Chile over here. So on behalf of Ambassador Olivier Porte d'Arvor and the French government, I'm very happy to be present with you for speak about what we are doing and how we intend to interact with you in the context of this One Planet Polar Summit, which is coming on in Paris 9th and 10th, 8th, 9th, 10th November. So thank you to the International Cryosphere Climate Initiative. Thank you to the Ambition on Melting Ice for this invitation. today, and we have just learned so much thanks to you. The Arctic and Antarctic are major strategic areas to the oceans, to which they are intrinsically linked, the North and the South Poles, playing a central role in regulating climate and preserving biodiversity. Actors and first victims of climate change, they are also the sounding alarm. Glacial worlds and high plateaus are also in a worrying state, as you have demonstrated. They show the extent to which the collapse of the cryosphere on a global scale can have effects on populations, ecosystems as a whole, water resources, and sea level rise. By organizing in November the One Planet Polar Summit, the first international summit dedicated to the preservation of the cryosphere, France is showing its involvement in the global efforts towards protecting our poles and glaciers around the world. To fortify its engagement, France, and that is the announcement, will join the ambition on melting ice that was created in 2022. At COP27. And I have even more that I'll keep for the end. It will join, so, the 20 governments that have first signed its declaration and pledge to protect the cryosphere through ambitious climate action. Even though we see our own alpine glacier melting, we are aware that the disastrous consequences of melting ice all around the world will affect low-lying coastal and mountain regions even more. Joining for us the AMI is as much a necessity for nature as it is for billions of people who will undergo floods, drought, and displacement due to sea level rise in the face of the crumble of the cryosphere. And I liked what you said about we can't negotiate with ice, but we can negotiate here and commit ourselves. The 2023 edition of the Paris Peace Forum, which is called Seeking Common Grounds in a World of Rivalry, will host, sorry, I'm French, will host this first international conference at a time when, subject to growing geopolitical tensions and increasing economic exploitation, the already fragile and glacial world and polar world are today threatened in their ecosystems. For the first time, researchers and scientists from over 40 glacial and polar nations will be meeting in Paris to share their findings and observations with experts from the IPSS and the IPBS, as well as with heads of international institutions, NGOs, representatives of indigenous people and local communities, and that's very important. The private sector, of course, involved in this region, and the political leaders of countries present in the Arctic, the Antarctic, but also in the glacial worlds. At some point, we call this the three poles. The 3-day conference will be dynamic, we hope, and will also involve the remote participation of researchers from the various scientific stations at the glacier, so you're all invited, and I need your cards if you have not been invited yet, international polar operators and great figures of glacial and polar exploration. So I want to say here and state here in front of my friend and colleague from Chile that not only we are joining AMI and it will be re-announced by President Macron, but what the President will announce in Paris during the Polar Summit is that by joining the AMI, we also want to propose a political declaration in November, and to double through a coalition the number of the polar nations who are, all the nations who are participating and supporting AMI. So from 40, we could perhaps aim at adding 20 to those 40. So let's work on that. We count on you, and please do count on us. And now I'll just say one word of publicity of the UN Ocean Conference, to which I'm specifically dedicated, which is in Nice in June 2025. There's going to be 2 special UNOC events, one dedicated to science and to scientists, and we hope to have you with us, 2,000 to 3,000 scientists invited to Nice to work and hand over the recommendations to the leaders when they would arrive on Sunday, the 8th of June, World Ocean Day, before the conference starts on Monday, the 9th of June 25. And while the science is being addressed in this special forum, in Monaco, your friends and our friends are partnering to organize at the Grimaldi Forum on ocean finance and sustainable blue economy. So science, finance before governance starts on Monday. We would definitely want to include the polar oceans in maybe both of these special events with scientists, but also when you come to finance, because the solutions that we need to propose will come only with new financing system, including the polar oceans. So that's the second way and route for our collaborations within the AMI, and rendezvous in Paris and then in Nice. And of course, we'll be meeting in the different forums of international global affairs, starting with COP28 in Dubai. So thank you very much, and congratulations for the fantastic work you've been doing and sharing here. Thank you.
Thank you so much, and we look forward to welcoming France in November. And I should note that, like Chile, actually, France was deeply involved in the process that led to the founding eventually of AMI. So again, most welcome. Our next reaction to the scientific presentations is from another founding AMI member, Mexico. Director General for Global Affairs, Camila Zepeda, has long been a leading voice on both climate and biodiversity issues. I should also say she is a leading advocate also for gender issues and women in the negotiations. And in addition to actually being reliant on snowpack for much of its water supplies, Mexico boasts a number of World Heritage biodiversity sites that will be inundated even with low levels of sea level rise. So please.
Thank you very much. I have to say I've learned a lot today, and I'm quite alarmed. I mean, we were already aware, but I mean, I think we're doing not our homework, and we need to do so much better. I didn't even know about permafrost. I'm like, no, I need a drink. I'm so sorry. But no, I'm really happy that you are pushing all of this knowledge, and we need us negotiators to make sure that everyone knows this data and knows what's happening, because there is a silver lining. There's still things to be done. It is still feasible. And so it is hopeful now that we are seeing some synergies happening between both the conversations in climate change and in biodiversity. Now, for example, with the adoption of the Kunming-Montreal biodiversity framework, that we have the target at 30 by 30, which includes also ocean territories. And now it's a part of the implementation and part of making sure that there are financial resources going. So very happy to hear from France that you are already thinking on that very integral perspective on bringing in ministers of finance that do need to take these concerns very seriously. And so hopefully that we are seeing now that more integrated work going ahead, because it will be much needed, and hopefully that we are up to the task on the climate change agenda. I mean, it is looking complicated, but we're hoping that at COP28, I'm sure that you'll have a pavilion, and I'm sure that we're doing some awareness raising, but hopefully that we do redouble our efforts. But thank you very much for having us, and hopefully that did make some difference. Thank you.
Thank you so much. Our final reaction will be from Ambassador at Large Kuban Kubayev of the Kyrgyz Republic. He is a leading voice, as is his country, on mountains issues, especially for this beautiful and many glaciated country. So please, Ambassador Kubayev.
Thank you, Pam. Hello, ladies and gentlemen. I'm absolutely delighted to be here after our meeting in Bonn in June. Good to see good friends and meet new faces. So I welcome France joining our initiative. It will add extra voice, I believe. Mira has made my job much easier, providing the scientific explanation to what's going on with the mountain countries. Kyrgyzstan is a mountainous, landlocked, developing countries. So we 90% of our territory, it's almost 200,000 square kilometers, are the mountains. So you can imagine the country split in two parts, northern part, or people live in a valley, and the southern parts, which live in the Fergana Valley and borders with Uzbekistan, Tajikistan, and China. So we're the home for the glaciers, and we are losing them, and in a very speedy way. This summer has stunned us. We didn't have that horrible summer before, at least in my 45 years. I have a birthday today, by the way. It was too hot this summer, and we didn't have enough water. For some reasons, glaciers did not pick up melting up until August. So all the meadows, all the fields have gone dry. So we lost the crops. That means bad for our economy, which heavily relies 30% of which agriculture producing. So this means that we will lose cattle. The farmers will have enormous losses. But maybe it's an opportunity for us, for consumers, to have a cheaper meat. So the farmers will start slaughtering the cattle and then marketing it earlier. So, and now I'm going to share my view. I think 1.5 is already enough damage for mountain glaciers. So they're melting. So, and I think they will continue melting. Not only glaciers, but we have hundreds of mountain lakes. They're also getting dry, which is bad, which adversely affects the flora and fauna of mountains. Ecosystems are getting rubbed. For example, Kyrgyzstan is a home for snow leopards. So when we host the International Secretariat for Preservation of Snow Leopards, and they prey, the mountain goats, they have to go down, in search for food. But snow leopards, they like cool weather. They cannot go down. If they do, they can become a victim of hunters, illegal hunters. So we are quite stunned what's going on, and I think it has come to general understanding of our population that climate change is a real threat. It's not a fiction, and the general population supports the policy course of the government. On going green. We have taken the commitment to decarbonize our economy by 2050. So we want to turn our gray economy into the green economy, to build more hydropower plants, to use less coal, maybe more gas if we have enough imports from Russia. But I think it's a crucial point that we have to overtake the things. Otherwise, we're going to collide with very uncertain future. Kyrgyzstan is a transition economy. It's a notion that has been designed by the World Bank and IMF in the early 90s when the Soviet Union was gone. And I think we stumbled in transition. So we cannot do the steps forward because many infrastructure projects are underfinanced. And we are trying to change things around. Our president, he's a supporter of the green development. So he traveled to Glasgow 26 and he declared about this decarbonization of the economy at much more ambitious scale than Russia or neighboring Kazakhstan, which largely rely on oil and gas. And for us, now we're working on bringing different climatic funds, to do the adaptation projects. I cannot say that we are a big polluter, and we have pollution at the local level during the winter because Coal is expensive. We will beyond the affordable reach of average population, so they try to heat houses by burning tires, clothes from the factories, remnants of the clothes, woods, whatever they have to burn. And it creates a lot of smoke in capital. Remember the story of Ulaanbaatar, capital of Mongolia, which of some 20 years ago, which barely was seen through the smoke. So they've done a good job. I mean, they totally fought the smoke, and this is a country we want to emulate, to take a good lesson from them. So we are on course of this, and so we need more international support. And we are trying, as a mountain country, to mobilize international attention at the UN level. So we were the founding country of the group of friends of mountain countries in the UN. So it's an informal group. So we invite everybody to join us to raise the cause of cryosphere around the globe. And we're also looking forward to participating in COP28 in Dubai. So our president is going to be there and to make a very harsh statement on the things that are affecting us as a small country. If we don't stop the rise of temperature, I don't know what will happen. At least from the point of Kyrgyzstan, we have a limited scientific capacity to forecast developments with the ice and with the water resources. We can only rely on international assessments, but at the national level it's very hard. So I also would like to invite the scientists, if you have an interest, to also look up at Kyrgyzstan. So I thank you at this, and I'm very happy to be here. Thank you.
Thank you so much. So this brings us actually to the end of our session. We need to get ready for the ensuing session, which will focus on the Arctic Ocean. And I wanted to thank all three of the policy speakers, especially also Ambassador Kabayev, for ending this and reminding us that although the effort that we're hoping to bring forward at COP28 is to essentially take 2 degrees off the table because of the response of cryosphere at 2 degrees, that for many countries, mountain countries, low-lying countries, even 1.5 degrees is actually too high. So thank you to all of the science speakers, to the policy speakers. We're coming towards the end of Climate Week, and we will look forward then to COP28 as well as Paris in November to move this agenda on ambition forward. So thank you, everyone, and have a good rest of your afternoon.